All right, the agenda is linked in chat. Feel free to add things. First up, from Gabby and Yuval to discuss string optimizations for attribute names.
Yeah, I can start. Maybe Gabby will fill up other things. So the idea is to try and tackle the S3 attribute names. So attribute names are the like the strings like x dash amz dash something something, and the idea is that those are relatively long strings. They're variable length, so they're dynamic, and they are kind of forcing us to use dynamic string allocation in several places. So they exist both in the messages. They exist in any kind of intermediate structure that we're holding this information inside the Redis gateway, and we also put them inside the objects. So, and the idea is that even though those are relatively long strings, we can actually hash them quite easily into just numbers because there's a very small number of them. I don't know, in a setup to be surprised if there are more than 100 different attribute names. So given all this information, we thought of building a system that would allow us to create a dictionary of those strings, and instead of saving all this information in all those names in all the places. So there could be a couple of levels for this. The basic one would be to just do that inside the RGW, so that the clients would continue to send us the same messages they sent before, and we'll just do the translation at the entry point and use those numbers from now on. I mean, after a pretty short period of time, we'll probably we'll see all the different attribute names. We'll probably see all the different attribute names that exist, and we would save on memory allocations and so on from the Redis gateway and on. And so this could be one level of optimization. Second level of optimization would be to actually send a translation table to the clients, and so that they could use it if they want. So of course, this is a much more difficult thing because it requires changes to the clients, and this is something completely out of our control.
Yuval, I think what we discussed was client being RGW and server being the OSD. So that way, everything is under our control.
Right. So if we do this translation at the entry of the RGW, then we can optimize that inside the RGW memory allocations and optimize that in the Redis objects. So that could be one level of optimization, what I described. A second level would be to actually send that to the S3 clients, and I mean, we don't really have to change or break the protocol for that. We can just send that as an attribute in one of the replies, and if a client implements that, then we will have the optimization kind of end to end. One client that we do control is in the case of multi-site. So when the client is another RGW, then we do control the implementation of the client, and we may optimize that in this case. But as Gabby said, even if we kind of put aside this enhancement to S3, which is always kind of a tricky thing, then we can optimize that inside the RGW, and in addition in the Redis objects as well.
Yuval, can I add a few things
Sure.
for the motivation on our side? The reason we wanted to try and optimize the attribute names is because the set of attributes that we use is pretty small. If you look at the objects that we have, we could have many millions of objects. And if you check how many attributes you got, probably a few dozens, let's exaggerate and say 1,000 separate attributes. So you'd see every attribute being repeated thousands times, and each time it's dynamic allocation of a short string. And when the object node is brought into memory, object string need to be allocated. When you go out of memory, deallocated. It's make encoding and decoding more expensive because, of course, encoding and decoding strings is expensive. And it also means that the data, that the attribute name is not continuous with the object node, because inside the object node, we have pointers into separate addresses. If we are able to replace them with short integers, and we are thinking about uint16, just 2 bytes, which would allow us to use 64K different attributes names, which is really unrealistic to ever get in this direction. So 2 byte instead of 16, or maybe more in some cases. It could be as large, I think, as 128 byte, but I think 16 byte is a more reasonable attribute names. But what we are be saving is not just 16 byte goes down to 2 byte, is move away from dynamic allocation, memory fragmentation, and the cost of encoding decoding. Actually, one more thing, every time that we process attribute names, so we search, it's a string compare instead of just doing an integer compare, which is, of course, much faster. And internally in the OSD, we really don't care about your attributes. From our perspective, attribute is just, it should match something. And if everything that we are processing it, we only see 2 byte integers, that's much faster operation on our side. And of course, we need to preserve the original name in case somebody needs it. That's why every time we going to replace, we create a translation from a long attribute names to a short integers, we need to persist the table. The end. Comment. Are we very clear, or nobody understand what we're talking about?
So I'm sorry, I got disconnected for part of the intro there, but it sounds like we're talking specifically about the X adders that we're storing on head objects.
Yes.
Okay, and at the Rados layer, all of the keys are strings. So where would we introduce uint16 translation?
We claim that there are very short set, very small set of attributes in use. In reality, it should be a very short set,
No.
so they could be hashed and
So
replaced.
Gabi, I think what Casey is asking is saying the API to Redis doesn't allow that.
API, yeah, that thing, we need to change it. That's what we're talking about. Redis API should be modified to support this change.
I mean, are you
And of
asking
course,
us
the OSD
if
would need to change to work with integer attribute names instead of string attribute names. That's another thing. But it's not crazy big change, and we think it's have some potential.
are you asking us if the Rados API changes in that way, then would we be willing to change our attributes accordingly?
Yes. It need to be a cooperative effort. Sorry, the OSD could do this thing internally just on the OSD, but I think it's more, it makes more sense that everybody would use this new change or this modified behavior.
So the main question is, it would require changes both to the OSD and the RGW and the API. Do you see the value here? Do you think this is something we should actually pursue in implementation?
I do see a value, especially on the OSD side. I'm just concerned about the complexity and backward compatibility of existing objects. So I mean, it might make more sense, instead of changing all of the keys to uint16, adding a separate API that supports the 16-bit keys and start converting things to use that instead. But still, I think there's complexity around mappings between strings and numbers, and also supporting things essentially like user-specified keys. For RGW, S3 has user-defined metadata, and we map those directly into attribute names. So there could potentially be more than 2 to the 16 unique user-defined metadata strings.
But is this really the case? I mean, have we seen thousands of user-defined S3 attributes? I don't think so. I mean, the current number of attributes is probably under 100. And if we take the user-defined, it could maybe go to a couple of hundred, maybe 1,000. So if we have 64K, this is kind of way beyond what we should have. But even if...
Right, but how do you map arbitrary strings down to 16 bits? You could use some kind of hash.
No. We don't want to use a hash here, because those strings could be very long, and we can have hash collisions. So the whole idea is that we'll just use some kind of a global counter for that.
So who is storing this global table of the global mapping of all strings to 16 bits?
The idea goes like this. Whenever you see a string for the first time, you access hash table looking for it. If it exists, the hash table going to... So let's say if it doesn't exist, you allocate an index, a running incrementing index, and assign it to it, saying the key is going to be the string name and the data is going to be the allocated index. If next time if you see the string somehow on your side, you have the strings, you map it, you get the string, you get the integers, and you use it from that point on. Every time we add an entry to the mapping table, that table needs to be persistent.
Right,
You could
and this
either
needs
persist
to
the whole
be...
table or just increment of that.
And this table needs to be globally consistent, right?
Yes. I was thinking using RocksDB object. And I don't think that, so in the beginning we would see the table being updated, but again, assuming that 1,000 separate attributes is a reasonable number, then after 1,000 update, that things is not going to be updated anymore, or hardly ever.
My other thought on that is like, how frequent are the user-defined ones, and is it really worth keeping a dynamic table for that reason, or does it make sense just to have a predefined, statically defined set of mappings for the common ones that are defined for S3, and leave the other ones still have string keys, since they're probably a marginal case?
So the user-defined ones, I mean, they're called user-defined, but in fact, they're used by applications, right? So it's not like every end user of the system is defining, like any end user or millions of the users of the system is going to define their own attributes. Nobody's doing that. So if you have an application using the system, they can add their own attributes, so they can store some extra information that they need. And so in a given system, the user-defined one is going to be a very small set of things, and they're going to occur pretty often, right? So if we're using some applications, and those applications are using those attributes, then we're going to see them over and over. So I don't think we should kind of look at the user-defined one.
I really buy that, though. I mean, the protocol itself lets you give arbitrary metadata names and values. Different applications might use different ones hard-coded, but a given cluster could have all kinds of different applications running at the same time. So I really think we need the flexibility of our arbitrary strings without the cost of a globally consistent table. So I think I agree with Corey that we should preserve the string-based API, but for all of the hard-coded attribute names that RGW already uses, it would be easy to convert those and just manage a mapping in RGW.
Sure. I mean, we don't suggest to remove the string-based one. What I'm saying is that if you look at the AWS CLI, for example, Border 3, they have user-defined attributes, but they're going to be all over the place, and they're not going to change. So it's like not everything which is user-defined is very kind of ad hoc, specific, and never kind of, some of the user-defined are so common as the non-user-defined.
So we could do a few things. So first, we could just create a very simple hash table and count just to see how this thing behaves. We could just load some testing utility and verify the actual number of different attributes used by client. Another option, if we want to have unlimited attributes, then use 4-byte. With 4-byte, your set is virtually unlimited. I cannot imagine somebody having 4 billion separate attributes unless somebody is doing something extremely crazy. But
I really don't think it's worth managing the globally consistent table of these things and having lookups that are racing between them, for example. So I think it's a good idea for RGW to use hard-coded ones, but I don't think we should be making assumptions like this for user-defined stuff.
Sorry, why racing if it's something that the OSD is going to determine and you guys just going to get the answer from the OSD? So the first access to the OSD, you're going to use the string, and then the OSD is going to tell you, you know what, from now on the reply message, please use this integer instead. That's easy. So you guys never have to worry about persistency. That's something the OSD need to manage. Persistency, consistency, race, any of these concepts should be internal to the OSD. Now the question is, if in reality people are using millions of unique attributes, then probably this concept is meaningless. If real world scenarios are using few hundred, maybe 1,000 attributes, then this concept have potential. But maybe you should just create a quick verification utility to check how many unique attributes we got. We could even create a scrub to do that.
Well, the problem is that we don't have access to all deployments, right? So we don't know how this is actually being used. But what I'm saying is that in many cases, the user-defined ones are actually almost standard attributes. They just fall into user-defined definition, but they're not. They're almost standard. They're used by the standard clients, not even applications, just a standard client implementation.
So going back to what Gabby said last, where the OSD is only managing its own table, I think that sounds fine. And I would go a step further and say to hide that mapping in the OSD and not change any of the Libredos APIs. So the client RGW would still be managing strings, but the OSD would have that optimization kind of hidden. I think that's where I would start, at least.
Yeah, I mean, okay. So it makes sense to start with the OSD, but in the long run, the greater potential is if the clients would also use the same integers. That way the OSD wouldn't have to do the translation on every IO, because the OSD doesn't care about the attributes name. From its perspective, it's just something it needs to preserve. So if every IO would require going to the hash table, finding the integers, assigning it to it, and that's not going to help the OSD very much.
Every IO is going to require going to the hash table and assigning integers. It's just a question of who does it.
Yes, we like the RGW to be the one doing this.
But right, okay. But
sorry,
that goes
because the RGW definitely have to see the full string. So there's no way to move around it. If anyway you have the full string, then go to the hash table and then you can get rid of it. Otherwise, you got it anyway, and you need to do string compare in every operation, but you also require the OSD to do this. So since you guys have no way to
distributed problem.
Sorry again?
So if the RGWs need a consistent hash table for these lookups, then it has to be distributed and consistent. And that itself is expensive.
The RGW doesn't need a distributed hash table. The RGW is going to get from the OSD trusted translations. And again, if we assume that the table is going to be relatively small with maybe 1,000 entries, you would get them from the OSD. Every OSD you talk to will just give you the numbers. And that's not the RGW problem, how we get these values.
So if the OSDs globally aren't replicating this table?
No, they should. The OSD should globally replicate the table, but the RGW can maintain a local cache, which doesn't need to be replicated, and it's okay to lose it. If you crash, the next time you restart, you'd get the full table from the OSD. So the OSD should maintain the persistency. RGW should have a shadow copy, but it's not the owner of the table. It just have a copy of the table.
So I get that the OSD is persisting this, but doesn't it need to replicate this table between every OSD in the pool
Yes.
or globally?
Yeah, sure.
Isn't that really expensive?
Again, if we're talking about 1,000 values, it's nothing.
It's not the data copy that's expensive, it's the synchronization that's expensive.
I know, but again, if we have 1,000 unique entries, then we need to apply 1,000 synchronization events globally.
No,
Why not?
1,000 synchronization events times the number of RGWs at least.
Okay, so you think there is 1,000 unique value per RGW?
I mean, each RGW needs to do a lookup for every string.
Yeah,
right.
But the question is, do you expect that every RGW is going to see unique attribute names?
I expect every RGW to see every attribute.
Right, but we said that globally we're going to have maybe 1,000 different attribute names, right?
Right.
So when an RGW first comes up, or whenever it has a cache miss in the local in-memory hash, which is kind of inexpensive, they're going to fetch the table from the OSD.
Right.
And assuming the change rate is really small. Like if we have 1,000 attributes, then they're never going to change after the initial ramp.
I mean, my understanding is it's not going to fetch the actual table from the OSD. It's going to say, I don't know this string. It's going to send the string down. The OSD is going to do a lookup, which involves a synchronization event, and pass back a number. And this is going to happen once for each attribute.
No.
That was how you described the API is working.
Okay, let me re-describe it. When the RGW doesn't have the integer, it's going to do the IO with a string. The OSD going to either find if the string exists in the OSD tables, is going to find it, act on it. There's no synchronization event here, and on the replay to the RGW is going to piggyback the value and say, from now on, please use this value. If the string doesn't exist on the OSD will need to synchronize with other OSDs this table entry. So that's a synchronization event, which going to happen on every time an OSD sees a new value. The question is how many unique value exist on the system. If every RGW have a unique set of attributes, then you're right, and it's maybe 1,000.
The RGWs are not the ones that have the unique set. It's the system that has those sets. The RGWs are not inventing attribute names. They're just getting them from the client. So the system is actually the one that has the different attribute names.
But okay, if we think about a cluster, how many unique attributes should we expect?
The answer is nobody knows.
I mean, I'm also a little bit worried about what the overflow behavior is, because I kind of expect that as soon as something like this gets deployed, someone will try to break it by just throwing in attribute after attribute after attribute.
No, this API has to be at least 32-bit, if not 64-bit. No question of that.
64-bit? How many attributes do you expect?
It doesn't matter how many attributes you expect. You can't define an API with 16 bits. That's ridiculous.
Okay, so make it 32 bits, but 64, it just seems crazy to me.
I mean, I agree with Daniel, but also I would like to know what the overflow behavior is, or how we're going to handle, like, Joe Schmo just flinging random attributes at us to try to fill up our table.
Or what if we get hash collisions?
We're not using hashing here. There's no hash collisions. We're not hashing those values.
So why, sorry, I guess I missed this. Why again is it required to be exposed to RGW instead of the mapping managed internally by the OSDs?
Well, my question is, why not? Why not do that on the RGW? It's a waste of our memory and CPU to do that if we need to do it twice on the RGW and on the OSD.
I think it's a lot of complexity, especially in changes to existing protocols. If we have something working at the OSD level and it's proven to work and scale, then I think it's a good idea to talk about the best way to expose that to clients.
We
But
could also, oh, sorry.
it's very non-trivial for writes in Librados to return data like this. And if there's a small limit to the number of bytes that an app can return in the first place. So if we're doing a setx adder with 20 adders, the OSD isn't going to be able to return 20 numbers for that mapping.
If we did want to do something like with this within the RGW, like I think we could do an interesting split potentially, where the OSD does its own version of compression behind the scenes without telling us, but similarly the OSD could have its own in-memory, basically its own in-memory table of interred symbols, boot things out when they get older, and just don't bother persisting them. Like we'll see a bunch of symbols come up and be able to use integer comparisons on them, but we won't persist them. But it should make the design a whole lot simpler and not involve, like Casey mentions, the Rados return issue.
I didn't understand this last suggestion.
If we want to avoid having to store and do a bunch of string comparisons in the RGW per se, we could simply have an in-memory table of strings that we populate while we're running, just by what we're seeing, and cut out the synchronization between the RGW and the OSD that way. Like we'd still ingest strings as we see them, and if we are seeing a constant workload, that should all get populated relatively soon after startup. We might still be able to get the benefit of replacing string comparisons with integer comparisons. And if we did something like that, since it's not a global shared resource, we could simply do an LRU type system where we evict where if we start pushing our numbers, we evict the least recently used 1,000 and go that way.
But what would you write?
What's the motivation here?
What would you write?
On this?
What would you write to Rados in this case? Like, let's say that we
I'd write string. I would write the string to Rados. The idea that was simply the idea of how, since you had mentioned the time and comparison use, I was just trying to think if there was a way to still get that advantage without necessarily having to pay for the Rados synchronization cost.
But you're still going to send the full string on the link, right?
To Rados, yes.
So when are you going to use the integer? Because every interaction...
no, just internally inside the RGW.
Yeah.
Just internally.
Are you doing a lot of comparison on attributes on the RGW?
I mean, if we
don't
aren't,
think
then
so. I mean, I don't think we are, which brings the whole thing into question. I guess we are insofar as attributes are stored in a map. And if you do a lookup on the map, then there's string comparisons. But maps are fairly well optimized, even string maps. But I don't think we will ever do a string compare on a user supplied attribute. They're user supplied. We don't ever look at them. We don't ever touch them. Right? We will store them and pass them through, and that's it. So there won't, I mean, the only string compares will be insofar as they're in the map with other attributes. And if that's a problem, we could have two maps, one for our known attributes and one for user supplied attributes. And then we would never do a lookup on them, and we would never do a string compare on them.
In that case, I think that's a pretty good argument for the Rados only view of it.
I mean, we wouldn't even need at that point a map. I guess you could just have a vector.
The motivation here was that if you guys could do this work or part of the work, and from my perspective, the work means the translation, not the persistency of the table, then you could save all the effort needed by OSD because the OSD wouldn't have to deal with strings since you anyway are translating them. But since persistency is requirement, then it means that the OSD should be the one doing setting up the translation, giving you the numbers, and once you get it and you have a cache of the values, then you could just use them from that point on.
So I think what Casey said before regarding the limitations of return value from write operation is a true problem here. So maybe we go, because you understand, Gabby, what we described as the API between the client and the OSD, replying with a couple of values is a problem if this number of values is too high. There are some strict limitations on the write operations to the OSD. But maybe you go back to the idea of the non-use defined attributes, like the known ones, and we really kind of hard code them as numbers.
Do the folks from Bloomberg on the call know how many user-defined attributes their cluster or clusters have, or have any idea if the number's low, like in the 4 digits, or if it's much higher?
No, I don't think we ever checked.
I don't think we have checked the user attribute, to be honest.
Can we maybe supply them with a small utility to do the counting?
Yeah, we'll do something like this
Yeah.
Yeah.
It's just like kind of figuring out the attributes.
So the user-defined attributes are those metadata, right? Like X, E, M, Z matter. Okay.
Yeah.
Okay.
Exactly.
Yeah, we can take a look.
So I mean, this would come up with CephFS also, right? Because as I understand it, they're mapping the POSIX X adders onto X adders in the same way, which could have arbitrary names and values.
Well, I guess they can take a similar approach if for the non-user defined ones, for the ones that are, I don't know if they have such attributes that always come with every file, then maybe they can just hard code them and then just pass them as numbers to the OSD. The OSD doesn't have to really care about that.
Yeah. I still think that just the OSD layer is the place to start. Find a design that the core team thinks is workable and get that working. And then the next step, I think, would be to expose a new Librados API, taking integers. But still in the RGW level, I think that's going to add a lot of complexity to do conversions, to store maps of attributes where the keys can either be strings or integers. It's really not clear to me that the cost of the string comparisons and allocations is worth all of that effort.
Well, for the non-user defined ones, we're doing we're doing lookups, which has the cost of hashing those strings, and of course we have the memory allocation costs. And for the non-user defined ones, it's the same string for each and every request, and for all requests, right?
Ivan, I think it should be all or nothing. I don't think there's a benefit in maintaining dual system.
So, I mean, RGW is already storing a ton of objects with string X adders. Is there any plan for the OSD to convert those? Or
You mean
do we have to?
Should we convert existing attributes? Maybe. If we would decide to go on this project, there will probably going to be some step in which the background process would start a conversion. But that's still in the future. I would start with brand new or on a new release, that everything on the new release for new installs, not just new release, just new installs. And then you can add a scrub process which should go back in time, should go over existing object and fix them. Can also be done lazy, so every time the object is brought into memory, you could just do that.
Hey, do we have an open tracker for this? If we gather some statistics, numbers, so where do we update?
Oh, there's no tracker. This was just kind of brainstorming the idea.
Okay.
But for sure, we can. we can summarize that and maybe an email, send that to the community, and put a tracker there, so the information could be aggregated in this tracker.
Okay, sounds good. Thank you.
So, I mean, has this been discussed with the Rados team at all? I think,
No.
yeah, I would want to get their feedback on the OSD side. Maybe a Ceph developer monthly or similar meeting would be a good way to raise that.
We can discuss that in the performance call.
Okay. All right. Any other thoughts here before we move on? All right, next on the agenda is bucket level redirect zone prototype. Is Eugene here to discuss this? I added a link to the PR that he opened about it. But I'm still not clear on the motivations there. All right, let's move on to Kernal then. Notification, retry, and cleanup.
Oh, I'm kind of following up. We had a discussion probably a couple of weeks ago, or maybe 3 weeks ago, about the notification retry, where you all was talking about should we come about a way on how to retry the so during our current notification testing, what we observed was the gateways were aggressively so we had a persistent notification setting, and our broker, Kafka broker, was on, but somehow it was not able to send in. It was kind of aggressively sending all the notification and crashing. And every time we brought up the gateway, it kept on sending. So I was just hoping an opinion here, like, is not there a way where the notifications or the persistent notification acknowledgements are retried for some time and then kind of give up instead of just doing it every time? Like we did discuss this last time, but I'm not sure if we reached a conclusion on this.
Yeah, I mean, you have to bear in mind this was because of a bug that we fixed. So, we shouldn't design a software around bugs. We should design a software around kind of system behaviors or network behaviors or environment behaviors. So, putting aside the specific bug that was causing the crash, do you want to not see retries of notifications? Let's say after the Kafka broker is brought up again, or the network recovered, or something like that.
So yeah, that's what my question was. Did we reach any consensus on what we need to do? I mean, there could be multiple approaches. I as an end user could wait for some time, and if it doesn't come up, kind of give up. I don't know. Like, how do we want to go about this? Like,
so the
yeah.
current behavior is that eventually you will get pushback. So there is a queue of retries, and when this queue fills up, then it pushes back. If you define that those notifications need to be sent for a specific bucket, then eventually when the queue fills up, maybe it will take a couple of hours, I don't know, then there'll be pushback on the client saying like busy or something like that, and you would see that the client needs to slow down. Now, I mean, this is the current design. If you think that a different design is better, then I'm open to changes here. But let's not discuss the issue of RGW keep on crashing or something. Because
I'm not discussing that issue at all. I'm just saying it's a scenario. I just brought up a scenario where this was happening and it was just continuously trying and never gave up, basically. So this could be a different scenario where the notifications are not being sent, but the gateway just keeps trying every time. Like, it just doesn't stop at all.
Right. So let's take like a scenario where there's a network disconnect or the Kafka broker is down. So the current behavior, I'm not saying this is the best thing or the only one that we should have, but the current behavior is that they'll be retried indefinitely because I don't know when to give up. And eventually when the queue fills up, then I would push back on the S3 clients. It might take some time, but eventually I'll push back on the S3 clients. Now, I mean, one design option could be to add like
a
time
default,
on the notifications, and then eventually I would give up and throw them away, and then maybe the queue won't fill up because I will be deleting stuff from there. This is one option, or I'm open to other options as well.
Just a couple of questions before we. What is the size of the queue that it decides when it's full, like 4 meg? Is it configurable or something?
So currently it's a single Redis object, the queue. So it's 4 megs, which means notifications are usually couple of hundred of bytes.
Sure. Depends on opaque data, actually. Yeah.
Yes. It depends on the length of the bucket names and so on. So it's not, but it's usually not more than one kilobyte. It's really that big. So
what happens when it is full? You said you do a pushback to the S3 client. So it's so your put operations would not, or just assuming like a put operation here, would not fill would not go and update the queue here.
Yes, I would. If the queue is full, then I would before I upload the object or do anything, I check what is the status of the queue, and I reply with a slowdown message to the S3 client.
But does the put operation complete? So
no. It's before I do the put operation. So before the put operation, I put like the queue works with a kind of a reservation system. So whenever I see a put operation that needs a notification, I make a reservation on the queue. And if I cannot make the reservation, then I immediately reply
503.
And if I can make the reservation, that I know that after I do the actual put, when I try to send a notification, which means to put something in the queue, I know I have a reservation, so I'll have space in the queue. So that's how the system works.
Okay, so potentially client would never be able to put an operation if the broker is down for them for some reason, and
Right.
they've exceeded
Right.
exceeded the object limit, like the 4 meg
Yes.
of the
Yes.
queue.
Yes.
Yeah.
Another option, sorry, just 1 second. Another option was to have, like, instead of this message queue, which is kind of a limited size, have like an infinite size, or use the message FIFO, and then it concatenates multiple objects, so you can have much larger size. I'm not sure if this is really where we want to go, because let's say if you decommissioned a Kafka broker and you forgot to remove the topic or something, then you don't want like a month of notifications to be unnecessarily consuming disk space in your system.
Yeah, I mean that's again an open for discussion, and that's what we think. We at Bloomberg have people sending in a lot of requests, so there are 100% chances for us where we would exceed 4 meg limits for sure.
Mm-hmm.
So again, way to tackle this is multiple things. FIFO is one option to increase there, but another option is to delete after few retries. Yeah, so again, that's the reason I kind of open this. I don't know what appropriate solution would be to this, but it would be nice to brainstorm on this.
Yeah, I can start an email thread on the user mailing lists. I'm just going to list a couple of options, and would be great if you can kind of reply with what you think, and then maybe other people, like other users of Ceph and notifications, can chime in and say what is the best option for them. I mean, we can implement all kind of things, but I would like to implement something that is most useful for most users. So
yeah, I mean, of course, we could always have an option of configuring as well, so this way you can cater multiple people as well. Like, yeah, we can discuss more on this. Yeah, so that was another thing, and then the follow-up for this was the cleanup thing. So as you said, right, like if the Kafka broker is down, or if you consider doing it a FIFO object, this space seems to be there. So if the tenancy is deleted, should we go and delete those topics, is what I was asking. Like currently we don't do that.
Okay, so currently currently when you delete the topic from the Redis Gateway CLI, Redis Gateway admin, then the actual queue is not deleted, but this is bug that we're fixing. When you're deleting from, like, after we fix the bug, or if you're deleting from the REST API from Redis CLI or Boto 3, then the queue should be deleted. I mean, this is tested. Maybe there's a bug there that doesn't work, but this is tested. So when I delete the queue, then I don't see any more retries or anything in this case.
Fair enough.
Your question regarding the tenant, I think this is kind of a wider question. Do we have like cascade deletions of anything when you delete a tenant? I'm not sure. Casey?
Sorry. Tenant is not actually a thing, so you can't delete it. I mean, you could delete all users under a tenant, but nothing knows, nothing's keeping track of whether a tenant name is used or not. They're just arbitrary strings.
We do have an option called as purge objects. So this way, when you remove a user, it also purge buckets, I guess, purge data. It deletes all the buckets and the objects belonging to that user, I believe.
But that's at bucket level. We're talking about tenant here.
Isn't that part of user as well? You remove user and purge data, that will remove all the data or all the buckets associated to that user?
Correct.
Right. So in that case, purge data should also go ahead and delete the queue as well, right?
I don't think the queue is associated with a specific user.
It is, right? I mean,
no, I think it could be used. The queue is really a representation of the end system that you're sending to. So you can do that per tenant, just to kind of as a namespacing mechanism to prevent collisions, but with the names. But
the confusion here is, I believe, from what I understand here, there is a one-on-one mapping between a tenant and a S3 user. There could be sub-users, but then a queue is specific, or you create a notification system specific to a tenant, right? And then associate it to a bucket. But if that tenant itself does not exist, that queue doesn't make any sense.
Sorry, I think there's a misconception about
Yeah.
tenant there. Tenant is a thing that originally came from Swift, and it's essentially just a namespace that's isolated from other tenants. So you create users under one tenant, and they can't view anything outside of that. So you can create several users and several buckets under a tenant.
Right, that's Swift. But in case of S3, like we create a single user, right? I mean,
No, it essentially works the same way for S3. It's just not exposed very well by S3 APIs. Users and their buckets can still be tenanted. You can still have several S3 users in a given tenant name.
so coming back to notification. So notification is it tenant specific or user specific? We have just done user specific things so far.
So I mean, there's a distinction here. The notifications are tied to a bucket, so they could be tied to a user. And also, if you delete a bucket, then all the notification configuration is automatically deleted. The topics are not tied to a bucket or to a user at all. They're namespaced by tenant, but they're not tied to a user or a bucket.
I see. So there could be two users or tenants / could have the same topic name.
Yeah, just a namespacing thing for the topics, but they're not tied to a specific user or to a specific bucket. I mean, you can have many buckets sending notification to the same Kafka broker.
So that's bucket. No, I'm just talking about topic here. So when you do a create topic during notification, the first step is to create. At that point, you create a topic which is specific to a user. You need to send in your user credentials.
Oh,
Without user credentials, you cannot send. Yes.
True.
So,
but that would be okay. So that's kind of a different thing. So you have to have user credential because this is how S3 works. But there's no association of this topic to the user. Any user can use this topic. We need probably to add some kind of a capability mechanism to make sure that only administrators can create and delete or modify topics, because this is really a system-wide definition. It's not a user or a bucket specific definition. It's only that because it's done over an S3 interface, or to be honest, over kind of an SNS-like interface, then you have to have some kind of credentials. But other than that, there's no tying of the topic created to the user that created it.
okay, so that means if you do a purge, so technically by that definition, purge data should not go and clean up the queue or clean up that particular topic, right?
No, the user, like once we kind of authenticated the credentials of the user that created the topic, we forget about the user.
Yeah.
We probably need to add kind of a capability verification mechanism to make sure that this user is allowed to create topics. But other than that, it's like an administrator. So when an administrator does something, then they're not tied to the user, which is the administrator.
Okay. I mean.
All right, so we're running short on time
Sure.
here. Yuval, you had offered to send a mail to the user list discussing the options here. Let's continue the discussion there.
Yep, sure. Thanks.
Thanks a lot. And Shilpa, are you on the call?
Yep. Hi.
I was just wondering if you had a quick update on multi-site testing for Reef. Do we have results from Mark on that?
Yeah. So Mark did provide me a Jenkins link, and he seemed to have been able to do a 400 million sync workload successfully on Reef. But I don't know if I think we would want to be able to integrate it in some way upstream. But yeah, we do have results for Reef.
Is this specific to the fairness thing, sync fairness testing, or in general?
No, this is just for the Reef release. It's not specific to anything.
Yeah, it's essentially the same workload testing that we did to verify the feature when it first merged, but I wanted to make sure that no regressions crept into Reef, and it sounds like we're looking good there.
Yeah, no regressions. It was fine.
Do we have any update on that sync fairness thing though yet?
Yeah, I do have a PR for that. I'm just gonna. I'll add you as a reviewer on it.
Yeah, we could pick up that PR, and if you want, we could provide the testing as well.
Yeah.
Testing for sure.
Yes, sure.
Thank you.
I have just pasted the link here on the chat.
Thank you.
All right, wonderful. Thanks, Shilpa.
No problem.
All right, so we're over on time, so we'll call it here. Some really great discussion. Thanks, everybody. See you next time.
Thank you, guys.
Thank you. Thank you.